everyone. So today we're going to talk about the average rate of change. And so before I get into what is exactly the average rate of change, I'm just going to propose this scenario to you. So suppose that the motion of my car traveling is represented by the graph below, where f of t represents the miles I have traveled, and t represents the amount of time I've traveled. Now suppose we want to find the average velocity my car traveled from t equals 1 hour to t equals 3 hours. And so the question here is how would I do this? Alright, well when we think about cars traveling, you normally say something like miles per hour, right? Like she's going 50 miles per hour. And so within the units there, miles per hour, you're basically telling me that's miles divided by hours. And so what does this remind you of? Well, this is really the change in miles over the change in hours, or the change in y over the change in x. Am I getting closer? Well, really what I'm talking about here is slope. And so to find the average velocity from t equals 1 hour to t equals 3 hours, I'm going to draw a line going through my 2 points to my graph here of f. Oops, there we go. Straight line there. Okay, and so the line that I just drew here, we have a specific name for this. We call this a secant line. And so below here I have the definition of a secant line. So a secant line is a line going through 2 points on the graph of a function f. Okay, so here you see in black that I have my function f, and so in blue here I drew the secant line going through the points t equals 1 and t equals 3. Okay, and so what I'm basically telling you is that to find the average velocity between my points t equals 1 and t equals 3, I'm going to find the slope of the secant line that I just drew here. And so that requires us to remember the slope formula, right? So here, I know that I need to write out my points. So my points on my graph, in particular that I'm looking at, are when t equals 1, I have that f of 1 is 25, so here's my coordinate 1, 25. And when t is 3, I have that my output value, or f of 3, is 50. Okay, and so basically, if I want to know the slope of this line, it's just like you guys have been taught in algebra, the change in y over the change in x, right? So more generally now, using like function notation, things like that, I'm going to say, okay, the average velocity between t equals 1 and t equals 3 is equal to f of 3 minus f of 1 over 3 minus 1. And so normally you saw that this was, y2 minus y1 over x2 minus x1. So you notice that this is the same idea here, where this is my my x2, my x1 here. And instead of saying y1 and y2, I'm just saying that this is, this is my f of 3. Sorry, I'll label it y1 and y2 to make us happy. But here, I'm just saying that this is my f of 3, and then this number here is my f of 1. Okay. And so plugging in here, I have that f of 3 is 50, minus f of 1, which is 25, over 3 minus 1. And so I get that this is 25 over 2, which is equal to 12.5 miles per hour. Okay, so don't forget the units if they're given.